And good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to take a look at section 6.3. We're going to actually spend 2 days on it because there's two different popular methods of doing the process we're going to look at. But before we do that, do you have any questions from yesterday's homework that you'd like to look at? I'll take that as a no. All righty, then we'll get started. So yesterday, we looked at factoring trinomials that were in this form, where the leading coefficient was an implied 1. Today, we're going to look at trinomials where the leading coefficient is something other than a 1. The process gets a little more complicated, and there are two common methods of factoring these kinds of problems. The first method is called grouping. If you'll recall, back in section 6.1, we looked at factoring by grouping. This method uses that. And then the second method is called trial and check, or guess and check, or the FOIL method. There's a bunch of different names for it. We'll be looking at that tomorrow. But today we're going to be looking at the grouping method, which I call the ABCPS method. And you will see why I call it that as we proceed, which is what we're going to do now. All right, so let's say we've got the following problem. 3x squared plus 4x plus 1. It is a trinomial. It is in standard form, descending powers of the variable, x squared, x to the first degree, no variable or no x at all, constant term, okay? There's no greatest common factor, and the leading coefficient is not negative, okay? So we've gone through all of that. So now what we're going to do, we're going to think of this as ax squared plus bx plus c. So a is 3, b is 4, and c is 1, referring to the coefficients of the three terms. Next, we're going to form the product of a times c. So the product is 3. And then the sum of b. So b equals 4. All right. So similar to the method we used yesterday, where we found a product. Oh, I used a b, and I should have said, hang on here. All right. The sum of b. So the sum is 4 because b is 4. My bad. All right. Similar to yesterday, we found a product and a sum, only instead of the product being the last term constant and the sum being the middle coefficient, now the product is the product of the first and last terms coefficients, that is a times c, and the sum is still b, the coefficient of the middle term, okay? You can already see where I'm getting A, B, C, P, S. So I'm looking for two numbers whose product is 3 and whose sum is 4. Well, how about the numbers 3 and 1? 3 times 1 is 3, so the product is 3. 3 plus 1 is 4, so the sum is 4. Now what I'm going to do, I'm going to take my original trinomial and I'm going to write it as 4 terms. I'm going to take the middle term and split it up into 2 terms whose coefficients are the two numbers that meet these two conditions. Now, I wrote 1x. I could have just left it x, but I wrote the 1 there just to emphasize that these coefficients go right here and here. Okay. Any questions so far? All right. Now I have a polynomial with 4 terms. I'm going to use factoring by grouping, groups of 2. The greatest common factor of the first two terms is 3x. The leftovers are x plus 1. So I need an x plus 1 from the second group, and I'll have to have a plus 1 outside. So now I've got x plus 1 times 3x plus 1, and there is my answer. Let's check our work. X times 3x is 3x squared. X times 1 is x. 1 times 3x is 3x, and 1 times 1 is 1. Combining like terms, 3x squared plus 4x plus 1, and this matches that. So here is the correct answer. Any questions about this particular problem? Okay, let's take a look at another example then. 2b squared plus 7b plus 3. This is a trinomial. It's in descending powers or standard form. The leading coefficient is not a 1. It's also not negative, and there's no greatest common factor that we can remove. So A is 2, B is 7, and C is 3. Now, I want to point out this B is not the same as the B that's the variable in the problem, okay? This B that's circled in red stands for the coefficient of the middle term. All right, so that's clear. The product is A times C, and the sum is B. I'm looking for two numbers whose product is 6 and whose sum is 7. 6 and 1, 3 and 2. Oh, 6 and 1. 6 times 1 is 6. 6 plus 1 is 7. So I'm going to rewrite the trinomial, but I'm going to write it splitting the middle term into two terms whose coefficients are 6 and 1. Trying to make that B not look like a 6. Anyway, then factoring by grouping, the greatest common factor of the first two terms is 2b, leftovers b plus 3. Greatest common factor of the second term, well, the leftovers would be b plus 3, so we're going to have a plus 1 out in front. Now the greatest common factor is b plus 3, and the leftovers are 2b plus 1. Let's check our work. 2b squared plus b plus 6b plus 3. Combine like terms. 2b squared plus 7b plus 3. And it checks. So this is the correct answer. Any questions about that? All right. Let's do this problem again. 2b squared plus 7b plus 3. Okay, A is 2, B is 7, C is 3, the product is 6, the sum is 7. Now, in the previous one, I wrote the numbers 6 and 1, which I then put 6 and 1. Let's just say I wrote 1 and 6. Okay, say I wrote it that way, because it wouldn't matter. That'd still be the same product and the same sum. And then I split this up and I wrote it like this. Will that work? How will that affect the answer? Well, let's take a look. Factoring by grouping. Greatest common factor is B. Leftovers is 2b plus 1. So over here, the leftovers is 2b plus 1, and I need a plus 3 out front. So I get 2b plus 1 times b plus 3. Is that answer the same as this one? Yes, it is. Remember, multiplication is commutative. So this times that is equal to that times this. So the order you put these just affects the order that the two factors appear in the answer. So it doesn't matter which one goes first in this case. All right. Let's take a look at this example. 15a squared minus 28a plus 5. So here we have a trinomial in standard form. It doesn't have a greatest common factor, and the leading coefficient is not a 1. So a is 15, B is negative 28. Let's make that a little nicer. And C is 5. The product is A times C, which is 75. And the sum, which is B, is negative 28. All right, so we're looking for two numbers whose product is positive. So that would have to be a positive times a positive or a negative times a negative. But the sum is negative. So we couldn't add two positive numbers and get a negative sum. So my conclusion, just thinking in terms of signs, is that we're looking for two negative numbers. All right. So now I'm going to go back and I'm going to start and say, well, I'll tell you what, how about negative 75 and negative 1? Well, that gives me the right product, but the sum would be negative 76. So I'm a long ways from where I want to be. Negative 75 is not even. So unlike yesterday, where I split the first number in half and then consequently doubled the second one, I can't do that. 2 doesn't go into negative 75, but 3 does. So how about if I divide the first number by 3 and multiply the second number by 3? Okay, so now I've got two new numbers whose product is still 75, and their sum is, oh, negative 28. That was easy. They don't always come that quickly, but this one did. All right, so here's my two numbers. So 15a squared minus 25a minus 3a plus 5. Factor by grouping. The greatest common factor of the first two terms is 5a with a 3a minus 5 left over. So I've got a 3a minus 5 left over there. In order to get this to be equal to that, I need to take out what? A negative 1, so that I get negative 3a plus 5. Okay, so let's get rid of all the extra stuff there now. So I'm going to take out a negative 1, which means I'm going to get 3a minus 5 times 5a minus 1. Let's check our work. 3a times 5a is 15a squared. 3a times minus 1 is minus 3a. Minus 5 times 5a is minus 25a. And minus 5 times minus 1 is plus 5. Combining like terms, 15a squared minus 28a plus 5, it checks. So here is the correct answer. Antonia, am I going too fast? Is this an okay pace?
Yes, yes, I'm just writing the notes. Yeah, it's going good.
Okay, all right.
Thank you so much.
If I get going too fast, let me know. Okay.
Yes, thank you.
All right, let's take a look at this one. 4b squared plus 15bc minus 4c squared. Now, this is in standard form in terms of the variable b, because we have b squared, then b, then no b at all. It's not in standard form in C. We could rearrange it and make it that way, but why fix it if it ain't broke, right? If it ain't broke, don't fix it. So it is in standard form in terms of B. There's no greatest common factor, so A is 4, B is 15, C is negative 4. The product is A times C, which is negative 16, and the sum is 15. All right. Now, the product is negative. So that means we have to have a positive and a negative, or a negative and a positive. So either that or that. But when we add those two numbers together, it comes out positive. So the bigger number has to be positive. So what I'm looking for is a big positive and a little negative. Okay. So in that case, I'd start out with 16 and negative 1, as opposed to negative 16 and 1, because that doesn't fit what we've already established by looking at the signs. Oh, well, guess what? There it is. 16 times negative 1 is negative 16. 16 plus negative 1 is 15. So 4b squared plus 16bc minus 1bc minus 4c squared. Okay. Factoring by grouping, the greatest common factor of the first two terms is 4b. The leftovers is b plus 4c. The leftovers is b plus 4c. And I have a minus 1c. So I could just write minus c on the outside, and that would accomplish what I need. So now I've got b plus 4c times 4b minus c. Let's check our work. B times 4b is 4b squared. B times minus c is minus 1bc. 4c times 4b is 16bc. And 4c minus c is minus 4c squared. Notice in my minus bc and my 16bc, I wrote the variables in alphabetical order so that it was easy to determine that they are like terms, which therefore can be combined. And that checks. So here is the correct answer.
I have a question on this one.
Yes.
Can you tell me how you got the product of negative 16?
All right. What is 16 times negative 1?
16.
No, it's negative 16.
Negative 16.
Yeah.
So that's where you got it. Oh, okay.
Yeah. The product of these two numbers is this, and the sum of these two numbers is that.
Oh, okay. Okay. Yeah. Okay. Thank you. Yes.
You're welcome.
That makes sense.
You're welcome. Okay. Let's take a look at this example. 16r minus 40r squared plus 25r cubed. Well, this is a trinomial, but it's not in standard form. So let's put it in standard form. 25r cubed minus 40r squared plus 16r. So descending powers of the variable. There is a greatest common factor we can take out, and that is r. So we get r times 25r squared minus 40r plus 16. Well, let's see if we're done. The trinomial inside might be factorable further. If it is, a would be 25, b is negative 40, and c is 16. The product, 25 times 16 is 400. The sum is negative 40. All right. So I'm looking for a pair of numbers whose product is 400 and whose sum is negative 40. Let's talk about the signs. To get a positive product, we've either got to have a positive times a positive, or a negative times a negative. But to get a negative sum, we can't add two positive numbers. So the two numbers we're looking for have to both be negative. I'm going to come over here so that I have more room to write. Okay. So I'm looking for two negative numbers. How about negative 400 and negative 1? So I'm kind of starting on the outer edges. Negative 400 times negative 1 gives me the correct product. The sum would be negative 401. That's a long ways from where we want to be. But negative 400 is even, so I can cut it in half and then double the second number. And I still get a product of 400, but now the sum is negative 202. Well, we're getting closer. Negative 200 is even. I can cut it in half and then double the negative 2. So I get negative 100 and negative 4, whose product is 400 and whose sum is negative 104. All right. Negative 100 is even. We'll cut it in half and we'll double the negative 4. Negative 50 times negative 8 is 400, and the sum is negative 58. All right. Again, we keep getting warmer. Negative 50 is even, cut it in half, and double the second one. That gives us a product of 400 and a sum of negative 41. So close, so close. So what do I know? Well, this number is getting less negative, and this number is getting more negative. And as we go, we're getting closer to our goal. So apparently we need a number that's less negative than minus 25 or negative 25 and more negative than negative 16. So can you think of a number between negative 25 and negative 16 that goes into 400? How about negative 20? Does that go into 400 evenly? How many times? Negative 20. Oh, and the sum is negative 40. So there's our two numbers. Now, that was a long ways to go. I'm not saying you always have to go through all of that, but this will work if you can't just see the numbers, if they don't just jump out at you. This is a process by, getting closer and closer, and then ultimately finding that number, hopefully. All right. Now, what are we going to do with that? We're going to take this, and we're going to copy that on the next page because I'm out of room here. Yeah, let's do that. So we get r times 25r squared minus 40r plus 16. And we came up with the two numbers both being negative 20. Okay. So I'm going to get r 25r squared minus 20r plus 16. Okay, splitting that middle term into two terms whose coefficients are the two numbers that we found that satisfy the product in the sum condition. Now, using factoring by grouping, we have an r outside, and then inside we have what? 5r times r minus 4, and then r minus 4. That's not right, is it? What's wrong? I'll show you what's wrong. I see what's wrong there. I got in too much of a hurry. This should be what? 5r minus 4 and 5r minus 4, because things weren't going to work out. I was going to panic there. This needs to be a minus 4 to get minus 20r plus 16. Okay. So now I've got r, 5r minus 4, and oh, another 5r minus 4. So this first one came from taking that out, and the second one came from the leftovers. Now, I could write my answer like this, or I could write it like that, because I have two identical factors of 5r minus 4. So either way should be correct. Any questions about that example? Okay, let's take a look at another one. 10u squared minus 13u minus 6. Okay, this is in standard form. There's no greatest common factor, and the leading coefficient is not a 1, because if it was a 1, I'd go back and use the method in 6.2. You don't have to do this unless this coefficient on front is something other than a 1, okay? Because this is more work. A is 10, B is negative 13, and C is negative 6. The product is negative 60, and the sum is negative 13. Okay, we've got a negative product, which means we've got to have a positive and a negative, or a negative and a positive, all right? The sum is negative, so that means that the negative number is bigger than the positive number, or more, has a bigger absolute value, okay? So we're talking, what are we talking here? We're talking a big negative and a little positive, all right? So because of that, I think I'd start with negative. I'll tell you what, I'm going to put it up here again, so I have lots of room. So I'm going to go with negative 60 and 1, because I need a big negative, little positive. That gives me the right product. The sum is what? Negative 59. Well, let's cut this in half, consequently double that. The sum is negative 28. Let's cut this in half and double that. The sum is negative 11. Okay. So each time I cut this in half, I doubled that, cut this in half, double that. That way I still get a product of negative 60. Oh, but look what's happened. We've gone too far. We've gone past negative 13 to negative 11. Negative 13 as a sum is between negative 28 and negative 11. So that means the pair of numbers we're looking for has to be between here. So one of them has to be between negative 30 and negative 15. The other one has to be between 2 and 4. Well, I don't know about you, but there's a lot less numbers between 2 and 4 than there are between negative 30 and negative 15. So I'm going to go with 3. And let's see, that would have to be negative 20. Negative 20 times 3 is negative 60, but the sum is what? Negative 17. So I went past the number I was looking for. I looked at the only possibility in this case in the middle, and it didn't work. So what is the conclusion? Anybody? It's prime, doesn't factor. Okay. Let's see here. What do I want to do here? I know what I want to do next. All right. 15c squared d cubed minus 25c cubed d squared minus 10 c to the fourth d to the fourth. Okay. Well, this is not in standard form in terms of c, and it's not in standard form in terms of d either. So let's pick one. I'm just going to go with c. So I'm going to have c to the fourth, c to the third, c to the second. Okay. Any questions how I got from that first step to my second step there? All right, now, greatest common factor, well, my leading term is negative, so I'm going to take out a negative 5 from the negative 10, the negative 25, and the positive 15. Then c squared, and then d squared. So my leftovers are 2c squared d squared plus 5c minus 3d. Okay, now, can I do anything with what's left in parentheses?
I have a question. How do you get to the negative 5?
This one here? That one? Abel? Abel? Can't hear you. Oh, you talking about this one right here?
Yes.
Okay, so that came from taking the greatest common factor out of the 3 coefficients.
Okay, got it.
All righty. So now, what about what's in parentheses here? That doesn't factor. It's not, yeah, it doesn't factor. So now, the reason I did this problem is because here's a mistake that students will make. They'll look at this and they'll say, oh, I can't factor that, so this is prime. No, it's not. Let's go back here. This problem, I couldn't take anything out. I couldn't factor it at all, so it's prime. This problem, I factored out that greatest common factor. Now, what's in parentheses doesn't factor further, but the entire thing is not prime, okay? So, yeah, see the difference between this one and this one? Hopefully there. All right. Let's see here. Let's take a look at this one. 25 n to the 8th power minus 49 n to the 7th power minus 2 n to the 6th power. This is in descending powers of n. Oh, there's a greatest common factor. I can take out n to the 6th power. So I get 25 n squared minus 49 n minus 2. Okay. What's inside? I have a trinomial in standard form with no greatest common factor and a leading coefficient that's not a 1. So A is 25, B is negative 49, C is negative 2. The product is negative 50. The sum is negative 49. How about negative 50 and 1? That gives me a product of negative 50 and a sum of negative 49. So I'm going to rewrite this as n to the 6th times 25n squared minus 50n plus 1n minus 2. Try to factor by grouping. N to the 6th. Greatest common factor of 25n squared minus 50n is 25n. N minus 2 left over. Second group, leftovers are n minus 2. And I have a plus 1 out front there. So going on, I get n to the 6th times n minus 2 times 25n plus 1. If you're having trouble with this step right here, go back to section 6.1 and revisit that whole idea of factoring by grouping, because once we split it up into 4 terms, we're using factoring by grouping. Any questions on that one? Okay, let's see. Let's do another one here. 8m squared plus 5m minus 10. It's in standard form. There's no greatest common factor. A is 8, B is 5, C is negative 10. The product is negative 80. The sum is 5. To get a negative product, I need one positive number and one negative number. To get the negative, or excuse me, a positive sum, the bigger number has to be positive. So we're looking for a big positive, little negative. So how about 80 and negative 1? Well, the sum would be 79. How about 40 and negative 2? The sum would be 38. How about 20 and negative 4? The sum would be 16. How about 10 and negative 8? The sum would be 2. Well, 5 is between 16 and 2. So we're looking for 2 numbers that are here. So it's either got to be a 19, 18, 17, 16, 15, 14, 13, 12, or 11, and a negative 5, negative 6, or negative 7. Well, there's less numbers to look for here than there are there. So let's try negative 5, negative 6, negative 7. Well, negative 6 and negative 7 don't even go into negative 80 correctly. Okay, in other words, I can't get negative 6 times something, to come up with a product of negative 80, and negative 7 times something doesn't give me a product of negative 80. So it would have to be negative 5. Well, what would the other number be? It'd be what, 16? What's the sum of negative 5 and 16? It's 11. So the only possibility in between, if there were three numbers, but only one of them would even give me a product, and that one doesn't work. So conclusion, prime. Now, a common mistake that students will make is instead of having some kind of pattern where they're working towards the middle, they'll just randomly pick some things. And if they pick a few and none of them work, then they'll say, oh, it's prime. But you need to do something like this where you're organized to such that I've narrowed it down to where I know the numbers have to be in the middle here. And when I try those, none of them work. Now I know it's prime. I get a lot of people on tests saying that a polynomial is prime when it isn't. They just didn't have a method of attacking it. So be careful with that. All righty. Well, that's all I have for you today. So I'm going to go ahead and stop the recording. I will be back at 1:15 this afternoon with an